Chapter 13, looking at light. So first thing we need to talk about is the fact that light is made of electromagnetic waves. And what you have is you have an electric field and a magnetic field moving along with the wave. So as the wave moves along this axis, the magnetic field moves along, say, our x-axis, while the electric field moves along the y-axis up and down. Electromagnetic waves behave like a particle and a wave both. We call this the wave-particle duality. So let's talk about the electromagnetic spectrum for a minute. In class, I'd have you research this, but I'm just going to start telling you some things. First of all, we start with radio waves. Radio waves on the electromagnetic spectrum have the longest wavelength and the lowest frequency. How do we use radio waves? Good uses are radio and TV. Now, as we shorten the waves, we end up with microwaves. And microwaves are shorter than radio, and they are more frequent than radio. How do we use them? Well, our microwave ovens, also radar, atomic research, various communication, like communicate with satellites and things like that, we use microwaves. So there's a lot of different uses for microwaves. After microwaves, if you get more frequent, you end up with the infrared. Infrared has an even smaller wavelength and a more frequent frequency here. And how do we use it? Infrared photography and physical therapy. As you can see in this image, you can see the person through heat. Infrared is the delivery of heat energy is often thought of as infrared. And a physical therapy, you can use it to do deep muscle heating. Following infrared, you go into visible light. And now we can see what the picture really was. It was Arnold Schwarzenegger. Visible light has a very narrow part of the electromagnetic spectrum. Here we have a smaller wavelengths, higher frequency, and duh, it's visible light. And you know what it's for. After visible light, if you look at the rainbow and you go Roy G. Biv, Roy is the red is over here, and Roy G. Biv V violet is here. So if we go a little past violet, we get ultraviolet with given wavelengths and frequencies. Again, smaller waves, more frequent. And a good use of ultraviolet light is the sterilization of medical instruments because microorganisms cannot handle ultraviolet light. They end up dying, just as we get skin cancer from ultraviolet light. Also, it shows off fluorescent minerals. That's why you can do the black light thing. X-rays follow ultraviolet, and X-rays, of course, the best use is to show pictures of bones inside you. Kind of neat. Here's a legitimate picture here of a knife in a person's head. That's kind of creepy. And lastly, gamma rays are the most energetic. They have the smallest wavelengths and the highest frequencies. And of course, cancer treatment. If you are getting radiation therapy, you are being radiated with gamma rays. Of course, they can also turn you into the Incredible Hulk. Then we have the equation C equals F lambda. C is the speed of light. Speed of light is 3 times 10 to the 8th meters per second. F is frequency, lambda is wavelength. And if you want to do a little homework assignment here, let me color the screen purple. And there we go. There's a homework assignment.